Welcome everyone and welcome to our sessions on artificial intelligence. So the topic that we'll be dealing on today is about image processing and computer vision. So already we dealt with the basics of image processing and computer vision. So we learned what is the whole difference between those two. Then we came across the simple operation of how to install OpenCV on your system, as well as to perform some simple reading and writing, as well as displaying operations on OpenCV. So the main concern of today is to do some more operations on OpenCV and find out what all the operations can we do about here. So the first thing that we'll be going to do is the simple operation. So the simple operation is called as splitting the colors. So splitting the colors into different parts. So that is the simple operation that we'll be doing. So it is also called as color splitting. So how to do this color splitting is pretty simple. So what I'll do is I'll just open Paint. So in Paint, what I can do is I can open a new file. So you can open a new file and you can set any size that you want. I will set a rough square so that it will be easy for us to understand. So what I'll do is I will take in 3 circles. So 3 filled circles. So one filled is of red color. So the second filling is of okay, I'll take the primary colors, red, green and blue. So the second will also be of green color. So this is green. So the color is also green. So then we'll take in blue. So the third one is blue. So the color of the third one will also be the blue. So we have taken 3 circles, red, green and blue circles. So that is what I have done. So I've just drawn. So this is the example that I want to show. So I will just save it as a picture. So I'll just save it as a PNG picture. So in my desktop, so I'll just save it as P1. So this is my picture that I'm trying to save. So you can take in any picture that you want. It's not a compulsion that you need to draw circles or anything. So for the convenience, I'm just doing it. So what is the thing that we'll be doing is, see, as I told you, each and every color that you take in. So each and every individual color that you take in or an image that you take in will be split into 4 parts basically. The first one will contain your the red color component, the green color component and the blue color component, as well as the coordinates. So each and every image will have all these properties. So each and every color image is defined by your red, green, blue as well as your coordinate. But in case of your grayscale image, it is defined by what we call as intensity. So intensity will be the gray or the white or the gray color. So you have your intensity that is defined between your absolute black and pure white. So that is the difference between your intensity. That is the intensity it is representing. So that is representing intensity, that is black as well as white color. So that is one thing. So then you have the coordinates. So this is the thing that is there in a grayscale or a black and white image. So in grayscale you will have varying intensity between 0 to 255. That 0 is indicating your pitch. Black, 255 is indicating pure white. So in black and white image it will be just 0 or 255. 0 black, 255 white. But here we have all the 4 quantities. So what we'll be trying to do is, we'll be trying to split only the red colored portion, only the green colored portion and only the blue colored portion of our whole image. So that is what we are trying to do. Then what we'll try to do is, we'll try to display them separately. So that is what we'll be doing today. So coming to the programming aspect, it is pretty simple. So we'll just import, okay, it's small letter. So import CV2. So you can import CV2, that is our OpenCV2 library. So what I will do is, first thing, so it is similar to your NumPy and Pandas where we do some simple operations. So whatever operation that you do there also, it is a standard procedure, right? So if you want to look into any image, you need to open the image and you need to take in that image and try to load that image in onto our program. So how do we do it? It is pretty simple. So the first step is image. So image is equal to cv2.imread. Okay, so what we'll try to do is cv2.imread and we need to mention our image name. So since I have saved it in the same file folder where I have placed my that is my Python file, so I don't need to type in my entire thing. So what I can do is I'll just type in p1.jpg. So what is p1.jpg? P1.jpg is sorry, that is a PNG file. So one more thing I forgot to tell you is your picture can be represented in many ways. So two specific formats we'll try to use them. So one is your JPEG and the other one is your PNG. So you can use either of them. So these two are the standard format which your OpenCV accepts. So either your image should be in PNG or JPEG. Okay, so that is fine. So if we have successfully read our image, so what we should print out is the image information. So what is the whole matrix of the values that we have. So just try to print that thing and we'll see how actually your matrix is getting printed. So if you have done it properly, obviously the values will appear. Yes, your values are appearing. So why you can see only 255, 255, 255? Because we have loaded this 255, 255, 255. So what is this? This is the RGB coordinates of some points. So why 255? So it is telling the point that is the surrounding points are white. So you can see, observe in this image. So observe this image. So most of the points are white, only except the 3 colored circles. So that is why you're getting most of the values are 255, but it is not displaying each and everything. So that is why it is keeping dots. So it is displaying only some values in the middle and some values in the starting. So don't get confused. So that is there in your image. Okay, so now image has been successfully taken as input through OpenCV. Now we need to split the colors. So splitting the colors is we have 3 colors. So we want to split the colors and we want to display them. So how to split the colors is B, G, R. So we have B is a variable that stores blue colored information. G is a variable that stores green colored information. R is the variable that stores red colored information. So how do we split it? So there is a function called as cv2.split. So this will split the component. So what is the component that you have? So the component that you have is the matrix. So what is the matrix that is that you saw already? So it is having R, G and B. So R, G, B coordinates of a, that is the color coordinates of a point it is representing. So this will split into B, G and R. So blue colored component will go to B, green colored component will go to G, red colored component will go to R. So that is what it is doing. Okay. So now what I want to do is I want to just split the particular image. So what do I want to split? I want to split this image. So image is the variable where I have already taken my my real image and stored it there in the form of matrices. So if I want to split it in the form of image, I will use cv2.split image. So now the splitting option is done. So if this command is correct, so then no error should occur when I execute this. Okay, so there is no error occurring when I execute this. But I am curious to find out what is there in B, G and R. So I will print out B first. So I will just print out B. I will see what is there in B. So B is nothing but a single dimension matrix containing values of your blue color. So what is how much of blue color it has? It is containing all these values. So blue points or blue colored points, it is there. Okay, so that is what it is doing. So you are having white colored points. So one thing you understand, white is represented by 255, 255, 255. If you have the maximum range is 0 to 255. So if you have blue, green and red as 255, so then white colored will appear. So most of the points here it is telling 255 because most of the points are actually white in color. So except your background and except some points, most of the points are white. So you can see this in image. So that is why most of the points are being displayed as your nothing but your white colored points. That is blue is represented by 255. So that is what it is doing. So if you want to see the colors or if you want to see the image where blue colored has been split separately from the rest of the color. So if you want to see that, so what you need to do is pretty simple. So if you want to see only the blue colored things, so we'll use the OpenCV operation to display the blue colored image. So the image which has blue portion. So how to do it? cv2.imshow. So what is the whole syntax of this imshow? cv2.imshow, you need to mention the window name. So window name will be blue. So it will have the blue portion of the whole image. So how do you represent it? By capital letter B, because it is the variable that has split. So our image has been split into blue, green and red portion. So B is holding the blue color. So blue colored portions of our image. So cv2.imshow blue comma B. So it is nothing but showing our blue colored image. So if you just open it. So you can see here, so how the blue colored portion is being shown. So one thing you need to understand, guys, so each and every image will have blue, green and red portions. So even your green color is, this is not the absolute green. So this green is also made up of little amount of blue. So this is not the absolute red. So it is also made up of some amount of nothing but blue. So red is also made up of some amount of blue. That is why you are able to see all the three circles. So you can see here, so you can see all the three circles. So the darker portions are telling that there is some amount of blue, and the lighter portion is telling that we have split it into different parts. So that is what we are able to tell here about the colors being split. So blue color component will be there. It is not that blue color component won't be there in other colors. But you can see how the data is being split. So how the data is getting more and more gray portion here in case of your blue. So how it is getting more darker in case of red and little more darker in case of green. So now let us print our red portion to understand how actually red is looking. So we'll just print out the red portion and we'll see how red is looking. So you can see here the original image is this. So wherever you can see your red image, so it is being split and it is being removed. So all the other portions are remaining. So except your original red portion. So that is how your splitting has taken place. So your original red portion, so it is closing to 255. That is telling that the color has been split. So if you want to see other colors and if you want to remove any one color and see the other colors, so this is one of the options. So your red color is becoming more and more whitish, or as you say, it is more and more going to your white levels or lighter gray levels, and your blue and your green is becoming more and more darker. So that is telling that how your color is being split into other parts. Okay, so now if you want to see the green portion, so similarly green portion will look more and more, grayish in color or more and more white in color, because the main thing what we are trying to do is we are trying to split the colors. So if I want to see the green portion, so green portion is this actually. So it is becoming more and more gray. So the other portions are becoming more and more dark. So this is what is all about your color splitting. So what is happening in color splitting is, if you want to split your blue color, if you want to split your green color, if you want to split your red color, so all the colors other than red, if you are choosing red, will become prominent. So if you are choosing green colored splitting, so all the colors except green will become prominent. So that is how it is splitting. So all the colors except the color you have chosen will become prominent, and you can see the darker images or the darker portions of that. Suppose you have a particular image, so it is a complete blue color image, you are not able to see any particular detail out of it. So if you want to do that kind of operation, so this image splitting operation will be very useful. Okay, so the next thing you might ask me is, what is the whole point of using all this? So you told me that it is splitting, so all the colors except the chosen color will become prominent. So what is the whole point of using all this is the question you can ask. So my example is this. So I will take a red color image. So inside a red color image, I'll just draw a small portion that is nothing but Python. So I will just draw a small portion that is Python. So I have written it in green. So this is not clear. So out of the red background, even though the green part is clear, so I am choosing a situation where it is very bleak. So the green portion is written in a very small text so that it is not visible at all. So this is now a sharp thing. So I will save this image. So now I want to split this thing. So if I want to split the red, green and blue, so what I will do is I'll split it into red. So if I split the red, all the colors except red will become more prominent. So if I want to check this, it is pretty simple. So what I will do is I will go to this, I will read this p1.png. So what I will do is instead of green, I will do red. So cv2.im show red. So I am trying to depict the image, or I am trying to show the red colored split image. So what will happen now? All the colors except red will become more and more prominent. So if I want to show here, so you can see the image for yourself. So our background was red before. So if my background was red before, so even though the text was visible, so the details were not visible. So due to the red background, details were not visible. So once I split them, I can see the whole black part. So it becomes a black and white image so that I can recognize the text more evenly. So this is the application of that particular thing. So very important, it is not just learning about the process or just learning about how your color splitting operations or anything. It is all about understanding how you can actually use them in your practical cases. Suppose you have some blue colored sheets or blue colored paper. So in that blue colored sheets of paper, what you are trying to do is you have written some message. You are not able to see that message. So what do? You color split. So if you color split into red, green and blue, what happens? All the colors except your red will become more prominent if you split it into a red portion. So similarly in the other portion. So that is how you are able to gain some knowledge or gain some entry into the distorted images. So very important. Why do you do image processing? So the main reason you are doing image processing is to find some sense. So how do you find some sense? It is either you are doing some operation to make it more and more clear. So that is what it is doing. Okay. So now coming into the mathematical part. So this is very beautiful thing to explain about the mathematical part. So what will happen in a red colored split or what happens in a blue colored split is pretty simple. So what happens in a red colored split is you are taking in the matrix. So the maximum color will be represented by 255. Minimum is 0. So if it is 0, that part of the color is not there at all. 0 portion of the color is there. So if you are taking into red splitting, what happens is red portion. Okay, you have your R, G and B. Okay, so you have your red, green and blue parts in each and every image. So your RGB image you are taking in. So if you split the color into red, so if you take in the red example, so what R matrix will have is R will become 0. So green and blue will be retained. So R portions are becoming 0. So R portions are nearing 0. Green and blue will be retained. So if R portion is like coming into 0, if green and blue are retained, what is happening? It is displaying the images. But why you are seeing it as a black and white images? These will become grayscaled image. So the output will be a grayscaled image. So the output is a grayscaled image where the intensities of green and blue are retained but red has become 0. So that is why you cannot see the red portion, so that becomes grey or that becomes white. So similarly in case of blue split, similarly in case of your green split. So this is the whole mathematics that is involved in this color splitting operation. So this is the way to understand that. Yeah, so the next operation that we will be dealing is actually called as addition operation. So we have a mathematical operation that we want to do. So what is this addition operation all about and how can we deal with this additional operation is the next question. So additional operations or addition operation is doing a pretty simple thing. So what we'll do is we'll consider a pixel that is nothing but R is 255. Then G is 230, then B is 32. So RGB value is 250, 230 and 32. So this is a pixel value. So now we have another pixel that is 21. So then we have around 250, then we have around 34. So these are the two pixels. So this is P1, pixel 1 and this is pixel 2. So what do you mean by addition? So it is the same thing. It is literally meaning addition. So when you want to add two images, so we are not trying to add the entire image. What we are trying to do is, since there are hundreds of pixels available in each and every image. So if there are like 1000 pixels on one image and 1000 pixels in the another image. So we are trying to add those corresponding images. So this is a position is 0, 0. So position of pixel 1 in image 1. So this is the image 1. So the position of pixel is 0, 0 and we have an image 2. So the position of the pixel is again 0, 0. So we are adding the corresponding pixels in each and every image. So one thing is IMG1 must be equal to IMG2. What is IMG1 must be equal to IMG2? The size of the image should be same to add. So if the size is different, your two images cannot be added. So very important thing is what addition is meaning is you are taking in two images, you are trying to add the RGB values of each and every pixel of one image of the other. So that is what you are going to do. But one thing is for sure, the maximum value which your R, G or B can take is only 255. So if you are trying to add any two images, what you are trying to do is, if you are trying to add your 255 plus 21 is greater than 255. So that remains as 255. Okay, so then again 230 plus 255 is, again it is 255 only, because it is exceeding your 255. It means that the maximum value that can take is 255. So then you have 32 plus 34, so it is 66. So you have 66. So this is the end result that you are going to get. So your R is 255, your G is 255 and your B is 66. So this is meant by your addition. So this is the addition operation. So what can you do with addition, or how will the addition operation be even useful? So that is very important, or practical implementation. So what I am going to show you is two images. So this is one image. So this image is nothing but just an image of a person. So I have drawn using paint. So one image is on the left side. So on left side I have a person here. So second image in the right side I have a person. So if I want to add these two images, the problem is I don't want to like combine the two images in a separate part, that is joining the two images. In this particular image itself, the same size of the image, I want to add another image. So is that possible? So that is possible with the help of your addition operation. So how do I do it? It is pretty simple. So what I do is I will just take in the example of OpenCV2 to add these two particular things. So how do I add it? So import CV2 to import my OpenCV package. So after I import CV2, I need to start reading. So how to read it? Image 1. So since there are two images, I need to import, or I need to read two images. So CV2.imRead. So how to read it? I need to give the name of the image. So i3.png is the name of my first image. So that is there. So if I want to read the second image, so image 2 is equal to cv2.imRead. Okay, so the second image, if I want to read, it is i4. So i4.png within a single quote. So that is telling me that the second image is taken into picture. So if I want to see whether these two images have been taken in properly, I need to use cv2.imShow. So I need to mention the window name. So image 1 is the window name. So then I can use image 1. So which is having the information of the i3 image. So if I have successfully imported them properly, so then I should able to see the image. Yes, I am able to see the image. So that is IM1. So IM2, I can change this as image 2 and I can try to see the image. Yes, IM2 also can be seen. So it is meaning that I have successfully taken in two images, image 1 and image 2. Then I am able to show them. That is nothing but I am able to print them. So printing is also possible, but I wanted to show how the image is actually taken in. So that is done. So I can see the two images. The two images have been taken successfully. Now the next thing is I need to add those two images. So how do I add the two images? It is pretty simple. So I will create another variable called as sum. No, so sum1 is better. Okay. Sum1 is better. So sum1 is the variable. So I need to add this. So cv2.add is the command. So what I need to add? I need to add my image 1, image 2. So this is there. Image 1, image 2 is added. So then what I need to do is pretty simple. After adding these two images, I need to display them. So how do I display them? It is cv2.imShow. Then I need to tell my window name. I can tell it as sum. So then I need to display it. So it is pretty simple. So what I can use is sum1 is the variable that I need to display. So this is the simple operation where we are trying to read two images, store it in image 1 and image 2. Those are the two variables. So someone is calculating the sum of image 1 and image 2. That is, it is adding the pixels. Each and every pixel is getting added. So then the addition of the two images are getting stored in sum1. So if I want to display the image, it is a cv2.imShow. So I'm just opening it so I can see that yes. So this is a perfect addition of two things. So one was my left aligned person, second is my right aligned person. So now I can add the two images properly. So this is the practical example where I can use this addition. Okay, so this is the practical example where I can use my addition. But one thing you can ask me, the background is black. Why is the background black and the person in white? So if I want to do the same reverse operation, let me check what happens. So if I want my background to be white and the person to be black, we'll try to see what is the operation that is going to happen. So this is very important to understand, guys. So what happened was we are trying to add the individual pixels. So there was a left aligned person image and the right aligned person image. Now the person is in white color and the background is black. So here also the person is white, the background is black. So now we can add successfully using our add operation. But I have another use case for you to check out. So what is the use case that I was talking is pretty simple. So I have a person that is nothing but a white background and a person or a cartoon character which is made up of black color. So this is one example. So then I have another background which is white and a cartoon character or a person who is made up of black color. So these two things I have. So these two images I have. So this is a right aligned one and this is a left aligned one. Now I want to add these two. So what happens if I add them? So I will change my image I1. So okay, I1 and I2 are my two images which I can use. So that is done. So if I want to display them first, so let me display them not to make any confusion. So let me display them. So I will comment this out. So let me display each one of them. So I will display image 1, IM1. So that is nothing but image 1. So if I want to display that, yes, it is getting displayed, so that is fine. So if I want to display image 2, so I will type in image 2 and I will display this. So these two are being displayed. Now the next thing is I want to add these two. So how do I add these two? It is pretty simple. Someone is same as my addition of image 1 and image 2. So what I do is I uncomment this. So someone is nothing but a variable which will store the addition of these two. Okay, so now what I will do, I will paste this code, that is CV2. So I want to display my someone. So now my entire image is empty. So why do I think my entire image is empty? So if we give some work to our brains, it is telling that this is the whole thing that we are trying to do. So once your image is 255, that is nothing but once you have a black image, so whenever you add 255 to 0, what it becomes? It becomes 255. So what is happening here is pretty simple. You have this image. So you have this image and you are trying to add it with the dead opposite one, that is the reflection of this. So this is the one you are trying to add. So what is happening is, whenever I try to add a right aligned image to a left aligned image, so since the pixel around here is white, so white, the intensity is 255, but black is 0. When you add 0 plus 255, it becomes 255 itself. So this has become this has become nothing but a white image itself. So white plus black is always white. So that is how it is trying to do. So when you add 255 to 0, it becomes 255. So that is why at the end, what are we getting? An empty image. Because the right aligned portion was white and I am trying to add the black image. So intense pixels are getting added. So at the end it became a white image. So black is 0. So when I add the counter opposite, that is nothing but this image. So this is white here. When I try to add it with a black pixel, so it is becoming white. So similarly, the right aligned image, when I am trying to add with this, so that is also becoming white. So the total image is nothing but an empty image. So this is the main issue when I am trying to do some simple addition. So there is some other method that you can use to solve this. So that is called as weighted addition. So I will tell you what weighted addition is. So if I want to explain you the concept of weighted addition, it is pretty simple. So we have my pixel 1, that is P1. So I have my pixel 2, that is P2. So both these pixels are at position 0, 0, and this position is this pixel is also present at the position 0, 0. And this is of image 1 and this is of image 2. Okay. So now what I have in picture is pretty simple. So if what I have in picture is the pixels, that is 240, then 30, then I have 160. So this is one pixel, that is RGB intensity. So next one I have, it is 120. So then I have 20, then I have 140. So this is the pixel intensities of my RGB of my second image. So what is this weighted addition is, since I told you if I add some image with the white background, the entire image becomes white, because if you are summing up something up to 255, so that is the maximum thing, so that will become white. So white plus any pure white image plus any image will be pure white only. So that is the main problem. So what is weighted addition is, you choose some constant weighted value, that is a decimal value. So the weight that I will choose here is 0.2. Okay, so this is the weight that I will choose. So here I will choose 0.4. So what happens is, this is the multiplying factor. So 0.2 is the multiplication factor and 0.4 is the multiplication factor. So what I do is, I try to multiply these two factors. So these two are nothing but constants, or we call them as weights. So when I multiply these two, you can see that the whole thing is pretty simple. So when I multiply 0.2 with 240, it is 48, then with 30 it is 6, and 160 it is 32. So if I add them, 40 plus 40 is 80, 88, and that becomes 96. So 96 is one sum. So then you have 6 plus 8, it is pretty simple, so it is 14. So then you have 32 plus 56, that is 88. So you have 88 at the third point. So this is the weighted sum. So what you are trying to do is, you are taking a decimal point, that is nothing but a decimal number 0.2 and 0.4. Then you are trying to multiply that with this RGB pixels. So the values are getting reduced. So even if I add them, so they are not becoming 255, 255, 255. So if I did the direct addition, 240 plus 120 would become close to 255. So then 160 plus 140 would become close to 255. So the image quality, or the image that I am trying to add, so if there was some white pixels, I would lose my entire data of the whole image. So what I am trying to tell you is pretty simple. So what I am trying to tell you is, if I had the image that is nothing but, I had the image of one image that is white image, so 255, 255 and 255. So the other image is nothing but 0, 0 and 0, the pure black. So what I will do is, I will use a multiplication factor that is 0.2. So similarly, I will use a multiplication factor of 0.4 here. So if I try to add them, so 255 into 0.2 will become 51. So it becomes 51, 51 and 51. So since if I multiply anything with 0, it will become 0, 0 and 0. If I add them, the output is 51, 51, 51. So if I would use direct addition, it will be again 255, 255, 255. So direct addition will be 255, 255, 255. So what is this? White. So what is this? Gray. So one thing to understand is, if you don't do weighted addition, so what happens is, you will lose the other image. So if your background, or if one image is white and the other image is gray or something, you would lose the entire image. But by using this multiplication factors 0.2 and 0.4, you are not losing out on the entire image. At least you are retaining the gray factor. So this is very important, and this is called as weighted addition. Now we will look at those two images, and we'll try to see how actually it is able to make a difference, or how actually you are not losing out on the data. So what you will do is, you will change this add to add weighted. So you will change this add to add weighted. So the same thing you will have. So earlier you are just using add, so you will use add weighted. So what you will do is, you will have two images, image 1 and image 2, but that doesn't work in the same way, because the parameters will change here. After image 1, you need to mention the multiplication factor. So what is the multiplication factor? I will tell it as 0.4. So the second image also, I need to add the multiplication factor. So what is the multiplication factor? 0.2. So these two are added, but there is one more thing to add. I will tell you what is. Okay, so the one more thing that I told to add is nothing but the gamma factor. So how this weighted addition is working is, alpha into pixel, that is nothing but the R or G or B quantity of image 1, then beta into R or G or B quantity of image 2, then the gamma. So what we are trying to do is, we are trying to add those components. So it can be done for colored images also, no issues. So what you are trying to do is, you are trying to add each and every quantity. So this 0.2 is pretty simple. So alpha is 0.2 now. So then beta, okay, what is alpha now? It is 0.4, sorry. Alpha into image 1 is 0.4. Beta into image 2 is nothing but 0.2. So why do we need this? Gamma is nothing but a constant. So what is this constant? You can add 0.2, 0.3 or 0.4. See, what you will do is you will add two images, but again there is some slight changes that you need to make. So if you want to add slightly some intensities, that is nothing but a correction factor. So you can take it as correction, that is nothing but you can add anything, or you can add some small value to make some brightness changes. So intensity or brightness changes if you want to make it. So you can add those two things. So this is how the entire weighted addition is happening. So if you want to check out the weighted addition, it is pretty simple. So I will add those two images. So I1 and I2 will become my images, that is nothing but these two images. So this is I1 and this is I2. Since I showed you just addition would get a blank image, so now I am doing a weighted addition. So this can be 0.4 is my alpha, so 0.2 is my gamma. So the whole calculation is 0.4 into image 1 plus 0.2 into image 2 plus gamma. So gamma you can give it as 0, 0.4 or anything. So that is correction factor. First I will give 0 and I will check what is happening. So now you can see that the first image and the second image which was blank. So the multiplication factor which I had more. So the multiplication factor which I had more was for which image? It was for image I1. So I1 was multiplied with a factor of 0.4. So when I multiply 0.4, so what is going to happen? Am I getting bigger values or smaller values? So if I multiply my 0.4, obviously I will be getting more values. So what I am doing is I multiplied my I1 with 0.4. That is why I am getting darker pixels here. So I multiplied I2 with the small with a lesser scale. So I am getting a lighter values here. So that is what is happening. So if you increase the scale, more intensity, better pictures you will get. So what you are trying to do is you are trying to add the multiplier values and trying to get the added sum. So this is the operation that we are trying to do. So if you want to change the gamma to 3, or if you want to change the gamma to some other constant value, you can change. Again, you will get the result. So they are just correction factors. So if you want to make it more dark, more brighter, you can add gamma to whatever value you want to. So if you add it to 20, then again, so there are some changes that is happening in the intensity values. So this is the whole concept of weighted sum. So you can try it with two colored images also. I have two colored images. One is called as R2 and the other one is called as RGB. So these two colored images I will try out. So R1.png and RGB.png. So R1, then RGB. So very important, two images must be of same size. So if they are not of same size, then they won't get added. Okay, so what it is telling is R1.png and RGB.png. So what is happening is there is no image called as R1, sorry, it is R2. So R2.png and RGB.png. So this is what I am trying to do. So you can see here what is happening. So if I am trying to add the two images, since it is a weighted addition, you can do it for the colored images as well. So what is happening? It is not subsiding anything, or it is not it is not covering up anything. The only thing it is doing is it is multiplying one image with a lesser factor and another image with a higher factor. So you are getting different colors and you are not losing out on the information. So that is what you are trying to do. So if I want to try out for uneven size of images, so I1 and RGB, if I try out, so it will give an error stating that it is not the same. So non-same sized images, you cannot perform the addition operation. So that is what you are trying to do here. Okay, so this was with the addition operation. So the last part is called the subtraction operation. So what is subtraction operation? We'll try to understand. So subtraction operation is very simple to understand. So how do I understand subtraction operation is very easy. So similarly, I'll take the same example. So what I'll take the same example is another pixel 1 here and pixel 2 here. So these two are belonging to image 1, img1. So the second thing is there is another image called as img2. So both are at the same point 0, 0. So what it is trying to do is it is trying to subtract my pixels. So how it is subtracting? It is pretty simple. So 250. Okay, it can be 255, 255 and okay 255, 20 and 30. And again, so here I have 0, 10 and I have 40. So what I will do is, if I subtract P1 minus P2, what I will do is 255 minus 0 will be 255 again. So then 20 minus 10 is what? 10 again. So then 30 minus 40 is minus 10. So that will add to 0. So whatever you are doing is, if the subtraction is less than 0, obviously it should be equated to 0. Because less than 0 doesn't occur in pixels. So the minimum value that you can take is 0 in case of R, G or B. So if it is less than 0, it will be taken as 0. So what you are trying to do, you are trying to subtract one image out of the other. So what is the resultant output that you get is the simplest thing that you can choose. So the simplest thing that you can choose is, you are trying to subtract each and every R, G, B value of each and every pixel, and then you are trying to find out the result. So how do you code it? I will choose an example that I have created here. So I have created a star here and I have created a small hexagon. So what I am trying to do is, I will subtract this star out of this particular hexagon. So what will happen? This small hexagon, the values are 255 for this hexagon. So white colored hexagon minus white colored star, what happens? So it will leave a black colored hexagon mark because I am subtracting those pixels. So 255 is white here. So this is also 255. 255 minus 255 is 0. So 0 is nothing but my black pixel. So how will I do it is pretty simple. So my image will be I5 and I6. So I5 is my image of my star and I6 will be the image of my nothing but my small hexagon that I have chosen. So I have taken in two images. So if you want to display, so you can again display. That is not an issue at all. You'll remove this. Okay, you can comment this out. So then you want to display this particular thing. So you can display it as IM1, so that will be image 1. So CV2 IM1, so it is getting displayed fine. I am able to take in my image. So then image 2, so I can change this to image 2 window name. So again it is appearing, so this is fine. So if I want to subtract these two, it is pretty simple. So I will call it as sub is a variable. So CV2 dot subtract. So CV2 dot subtract, the command is pretty simple. It is CV2 dot subtract is the command. So what I want to subtract, I want to subtract my image 1 from my image 2. So subtracting image 1 from my image 2. Now I will try to print the image 2. So this is not printing, it is displaying image 2. So I have subtracted the values. So now what will I get? Sorry, I'm just printing out image 2. I should have printed the sub value. So I need to print the sub value. Now what I'm trying to get is, I'm getting a small black colored pentagon hole here on my star because I have subtracted this pentagon out of my star. So white minus white, 255 minus 255, all these values became black again. So the background, everything is black because 255 minus 0 will be 255 only. So the whole image is retained. So this is an example of subtraction. So this is the basic arithmetic operations that you could do with OpenCV. So with this, we end the arithmetic operations part of OpenCV. So thank you guys.